We talked about what is probability. We talked about what is basic probability. We talked about the law of large numbers, and that's what we talked about on Friday. Now, right now, I'm trying to get to make sure that thing's up. Thought I pulled it up, but evidently I didn't. Make sure my Word document cam is up. And there it is. Okay. Got that up. Got this up. And now we are ready to go. 11.1. Okay. Go ahead and start you on this one. Now I'm gonna pull up the, go ahead and write this slide down. I'm gonna bring in my visualizer. I'm gonna move it to the side. Go ahead and write that slide down. We're talking about a fair die, which means one die out of two. So y'all played Monopoly before, so everybody's played Monopoly knows what a pair of dice is. A pair of dice is two die. One dice is called a die. I don't know if anybody knew that or not, but most people don't know that. I know I didn't. So a fair die is rolled. Find the probability of rolling a 2, an even number, a number greater than 3, and a 7. So while you're writing that down, I'm going to write it down because I'm going to tell you, like I told y'all before, in probability and statistics, it's not the math that gets you, it's the reading. So,
priority 1 message coming in on secured channel.
A 2. B, an even number. C, a number greater than 3. C, a number greater than 3. D, a 7. And E, a number less than 7. Now, this is a good slide, but I'm going to go to it and let me check on this because this is the person that says that they have a new number probably. You are on Skype. We use Skype for business. Please read the handout. Yeah, he's using his phone number. That's telling me that he's on Skype because you can't use your phone number on Skype for business unless you want to buy it. Anyway, okay, people don't read. All right, so I want to do the probability of 2. Well, how many sides does a die have on it? It's got a 1, a 2, a 3, a 4, a 5, and a what?
A 6.
A 6. So how many sides does a die have?
6 sides.
6 is your denominator. And how many 2s do we have?
1.
1. I'm going to do these in different colors. Y'all are so blessed. How many evens do we have?
3.
3.
How many are below 3?
1.
2. I just circled it. Okay, there's a delay. I'm sorry. How long of a delay is it? A couple of seconds? 10 seconds?
Yeah, a couple of seconds.
Okay. All right. So that circle right there, I just did less than 3. Now, what do you got to be careful with on inequalities? What do you got to be careful with? Not only less than or greater than, but what else? What's the other two?
Less than or equal to and
Less than or equal to or greater than and equal to, and that would include 3 if you had a little line right there, so you got to be careful. Okay, 7. What's the probability of 7? Well, where's your 7 up here? You don't have one. So if you don't have a 7, what does that mean? 0 out of 6 times. That's a trick question. You will see that question on a standardized test, and people will miss it. What numbers are below 7? What numbers
6.
are below 7? All of them.
6.
Now, this problem is perfect for what I tell students. It's not the math that gets you. It's the reading of the question. I'll give you an example. This question right here, people miss because they don't use critical thinking. People miss this question because they what? They include 3. And people miss this question, again, because of the critical thinking. So it's just like I'm telling my 103s with the income tax. It's not that people can't add and subtract numbers. That's not the problem. The problem is that people can't read, or they assume what they're reading. And that's what's going to get you in probability. That's where you'll get a wrong answer. Is when you start, oh, that's what they're wanting. No, don't. You better read it. Okay? So those are real basic test questions, but all 5 of those could be a test question in 11.1. Okay? And what kind of probabilities are these? Are these physical probabilities or theoretical? They're theoretical because I don't have a die in front of me and I'm not rolling. So all of these are theoretical. And there's supposed to be an H in there. I think it's right there. No, it's just theoretical. Okay. Why are they theoretical? Because they're based on what? Do I have a die in front of me? No. They're based on 100% math / what you know of a die. Now, you actually have a die, and let's say that Mr. Hill was sitting there with a die at home, and he was rolling a die, and he got 5 2 times. Then the probability of a 5, the physical probability, is 2 out of 6. Always reduce, too. Always reduce. I didn't on this because I wasn't trying to teach you to reduce. I'm trying to teach you to read the question and get the answer from the question. Y'all know that this is 1/2, and this is 1/3, and that's 0, and that's 1. Okay, I'm not worried about the reducing. I think y'all have had 12 years to know that if you have a fraction, you need to reduce it for the answer. Also, make sure they may ask you to change them into what? Decimals. Okay? So that is 5 test questions right there. So don't mess them up. Okay, next question, next slide. And the next slide, I'm going to move this, I'm going to minimize this now. And we'll see whenever I come up to another where I need to use my document cam, I'll just switch over. So we did those. Okay, the probability of an event that cannot occur is 0. Now there's a test question on this one. And I'm going to write it down right here. And I'm going to let y'all write this one down. Y'all write what's down on the slide. You got the corona just because. Huh? You don't have the corona?
No, sir, I don't have the corona. No, sir.
Okay. Make sure you get tested. No, I'm just kidding. That way the local news can go even crazier. Just because. 0, 0. Okay, I'm going to show you what I just wrote down. And it kind of goes with what this says. I just like to write it down to reiterate it, especially for a test. Just because something has a probability of 0, does that mean that it's impossible? No. One thing that people assume a lot of birth control. What do people assume about birth control? They assume if they use birth control that you won't get pregnant, right? But is that a safe bet? Yes or no? Y'all supposed to interact with me.
No.
No, thank you. Mr. Hill, are you aggravated with me?
No, I was just waiting for someone else to say it, so I just
I
wait
know,
for it.
it just blows my mind how people don't communicate. Birth control is something that assumes, people assume that if you use it, it ain't going to happen. All right? This word is a definitive word. Okay? Let me give you another definitive word. Another one. What do all those words have in common? Here's another word. I'm trying to use different words with different meanings to try to give you the meaning of what I'm looking for. What do these words all have in common? Impossible, perfect, exact, infinity. What do they all have in common? Anybody want to take a stab at it? Or do y'all just want to say that y'all are losers and y'all should quit school? Okay, nobody's going to say anything. You know, y'all don't have to mute your microphones. I don't think the lag is that bad. But anyway, I would probably say, okay, let me ask you this. How many of y'all have seen these 4 things?
I haven't seen those 4 things.
So what does that mean? They're hard to what? They're hard to reach.
Find.
Yes.
Oh.
They're hard to see, they're hard to reach, they're hard for you to fathom. What does that mean? They're hard for you to really think about because they're definitive. Okay? Exact. Okay? Are you ever going to hit an exact amount when you're trying to figure something? Very rarely will you hit the exact amount. Impossible. Everything is possible. Anything is possible. Perfect. Nobody ever reaches perfection. Infinity. Nobody ever touches infinity. So these words, when you see these words in a probability context, what should you immediately think when you see these words in a probability context? There ain't no way. So whenever you see one of these words in one of your multiple choices, chances are, depending on the context of the question, let's say that it says, there's one question that talks about exact, and they say the average is exactly blah, 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 blah. Never in probability do you use the word exactly. Never. You never use the word impossible either. So these two words, if you see these two words, chances are, unless they're telling you, so this question says, the test question that I'm thinking of, a probability shows to be 0. Does that mean that it's impossible? And you say false. Nothing is impossible. Okay? So make sure you make a note of that question. And this question also, you'll see this question either in 155 or 120. And it'll say something to the effect, you have calculated the blah, 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 and it hits exactly on your prediction. Well, when you see the word exactly used, that's not a good word to use in probability. Okay? That gives you a little bit of what they're going with that slide. The probability of event that cannot occur, a probability of event that must occur. Every probability has a number between 0 and 1. We've already talked about this. So go ahead and write those 4 things down. Oops, sorry. Okay, the probability of an event that cannot occur is 0, but not impossible. You need to put, but not impossible. The probability of an event that must occur is 1, but not inevitable. What does inevitable mean? That means that event is going to happen no matter what. I don't know if I'd use that probability. I don't think I'd use that tone. Okay? I would say the probability is very, very high, but I would not use the word inevitable. And that word must, I don't like that word must in probability. Now, if they say the probability of an event that has a high probability is 1, I like that. But I don't like that word must. What do you think of when I say the word must? You think of concrete. You think of it must do it. Now, in probability and statistics, nothing is in concrete. Nothing. As far as interpretations. Probability of the area under a curve, the percentages that you're talking about are going to be between 0 and 1. That's a very important rule for probability. That is a test question on a standardized test. Every probability is a number between 0 and 1. It can't be negative, and it can't be above 1. So if you see one that's negative or see one that's above 1, just mark it out because it's not true. The sum of all the probabilities of a possible outcome is equal to 1. What's the probability of flipping a head? 1/2. What's the probability of flipping a tail? 1/2. Add them together. 1/2 plus 1/2 equals what? A whole. Tell me when y'all get through copying number 4 down. Question, great. guess y'all got it written down.
Finished copying, sir.
Huh?
I'm finished copying it, sir.
Okay, thank you, Mr. Yap. All right, next. Okay, we're not going here. I'm gonna go to there's a better way of explaining that. The word complement, write that word down, complement. I always have to check the spelling of complement because there's two ways to spell it. Complement in mathematics is C-O-M-P-L-E-M-E-N-T. Complement. The complement is the number that makes up the whole. Now that's a Hubertism definition. You're not going to see that in any book, okay? So let's say you have $1. You have $1 in your pocket, $1 worth of change in your pocket. Nickels, dimes, quarters. You can have pennies, but you don't need pennies. And I tell you to give me 35 cents. Then what does that leave you? What does that leave you? 65 cents. 65 is the complement of 35. 35 is the complement of 65. What's the complement of true? Complement of true is not true. Some people may say false. If you talk to a statistician, they'll probably cringe. But since this is the introductory level, we'll say false. The complement of guilty, be careful here. A lot of people here would say innocent. No, innocent shouldn't even. The opposite of guilty is not guilty. Some people would say innocent. Well, in this case, I'd have to call you on it. Because let me ask you a question. I'm going to ask Mr. Hill this because he's the only one that's going to talk. Mr. Hill.
Yes.
Is OJ innocent or not guilty? Why'd you laugh?
That's a, I don't know how to answer.
Exactly. Because,
Yeah.
okay, now, a lot of people say, well, he was innocent. No, he was found not guilty. Not guilty and innocent is let me give you an example. Let's say that Mr. Yap, let's say that he works at Domino's Pizza. And he's been working there for 2 or 3 years, and he goes to school, and he is an assistant manager, and the manager has said that he needs to go into business so he can get, so he might buy some franchises, and he's just doing real good. He's working 35 hours a week and going to school, and everything's hunky-dory for Mr. Yap. And
Heck
Mr. Hill is Mr. Yap's roommate. They both go to school. Mr. Hill don't work. He parties all the time. He don't have a job. And he bums off of Mr. Yap all the time and never pays rent. And one Friday night, Mr. Yap goes to work or has to go to work at 5 o'clock, and he gets off at 1 or 2 in the morning. So Mr. Hill wants to borrow Mr. Yap's car. And Mr. Yap says, okay, just take me to work and pick me up. And he borrows Mr. Yap's car. And Mr. Yap works until 2 o'clock that next morning. And Mr. Hill comes and gets him. and they get back to the apartment and they go to bed. The next morning, the police knock on the door, and they take Mr. Yap off in handcuffs, and they take him down to the police station, and they say that his car was used to take a log chain and tie around an ATM and pull it out of the Minute Mart. They got pictures of his car. Will Mr. Yap ever see the inside of a courtroom? Yes or no? No, he will not. How can you say that, Hubert? Well, for two things. One, what is it all businesses now when you're working? What's it all businesses now? If you work at a bank, if you work at a pizza place, what do they have inside the building now?
Cameras.
Cameras. So there's going to be a camera saying that Mr. Yap was at the Domino's establishment from 5 o'clock until 2 o'clock. What else? Who else works at Domino's with Mr. Yap? Have you ever been to a Domino's? It takes like 15 people to run a Domino's. Okay? So there's about 15 people there with Mr. Yap that can be what? Witnesses. So after he gets through telling his story, Mr. Yap is let go, and they come knocking on the door for Mr. Hill. Mr. Yap will never see the inside of a courtroom because Mr. Yap was 100% innocent. Why was O.J. in the courtroom? Because he could not produce a valid what?
Statement.
Statement or alibi. He could not prove that he was somewhere at that time. Nowadays, it's easy to prove an alibi. Why? Because of all the cameras. Okay? There's cameras up on every telephone pole in the city, on every block. It's hard. It would be hard to commit a crime and say, you know, I cannot say where I was unless you were home alone. That's the only way. So in this case, Mr. Yap would be 100% innocent because he had two alibis. He had cameras and he had the eyewitnesses at Domino's saying that he was innocent. So when you're talking about a compliment, you've got to be very careful. Okay? What about, let's say that there's 500 people that work at Domino's. And 200 are sick with the dang old coronavirus. All right? So what's the complement of 200? 300. Or what? Not sick. So you can do it with a decimal. You can do it with a word. And you can do it with a quantity. This is very important. You need to write this slide down because later on, if you ever come back for a bachelor's degree or another associate's degree, and you need to take Math 120 or Math 103, you're going to get into this a little bit more. Okay? So if I tell you that you need to find the complement of something, the complement is always 1 minus the event. Okay, here's a good example. What's 1 minus 0.35? 0.65. What's 100? What's 500? This is the event because it's not 1, it's a quantity here. This is a quantity. Okay, this is a probability. okay? Because it's 1. All right? So what's 500 minus 200? 300. Now, if you wanted to turn this into a probability, you would say 200 out of 500 is 6, and that would be a decimal. And then you would 1 minus that decimal, and that would give you how many is not 6. So you can turn it into a decimal if you wanted to. So the whole concept behind the complement is what makes up the whole. Whether the whole is a probability, whether it's a concept, or whether it's a quantity. I'll give you another example of a concept. What's the complement of black? I want y'all to answer. What's the complement of black? Y'all don't know what the complement of black is?
Complement is in like, would it be gray? I don't know.
No, complement would be the opposite.
White. Ah,
White.
there you go.
Okay. What is the complement of 0? 1. What is the complement of, I can't think of any right now. What is the complement of odd?
Work email.
Even.
There you go. So when it's concepts, you could say either even or you could say not even. So that's what they're talking about with the with that. Okay. Now sometimes you'll see the complement written this way. I want to show you the different ways because I know there's a test question. I can't remember if it's on this test or 120 or 103. Complement can be written 4 different ways. 1 minus the probability of the event. That's one way. Or it could be written probability of an event with a line over it. Or the probability of an event with an X through it. I'm going to do the X in a different color. Or this one I haven't seen a lot of, but I've seen it on a test. Complement of E. Or it'll have a C in there somewhere. Okay? Oops, I'm sorry. Can't see it. Duh. All right, write those down because those are different ways to write the complement. And again, if you've had probability and statistics before, you probably remember this stuff. And if you haven't, then I'm going over it for the first time for you. Yeah, our fellow must be reading, must be trying to find the handout or reading the handout. That's a good thing. Always read that handout before you log on. All right, so that's the complement. I got 3 minutes, I think. And let's go back to the slides. You need to know not only a die, but you need to know a deck of what? Cards. In standardized testing and in my test, you need to know a die. You need to know a deck of cards. So make sure you know, get you a deck of cards and start counting. Okay? How many suits are in a deck of cards? There's 4 suits. Those suits are hearts, clubs, spades, and diamonds. Diamonds are what? What color are diamonds? They're red, and hearts are what?
Red.
And the clubs are black, and the spades are black. Each suit has how many cards? 13 cards. Each has 13 cards. And those 13 cards range from 2, or ace, from ace to queen or king. Ace to queen, king. Ace to king. And ace to king. So make sure you know your stuff. Again, a lot of people don't miss the question because they do the math wrong. They miss the question because they don't know how many face cards are in a deck of cards. What is the probability of a face card? Well, there's 3 face cards in each suit. There's 4 suits, so that would be 12 over 52. Now, I'm not going to worry about reducing. Okay, let's just go ahead and say that right now. For those people watching the video and for people watching Skype, you worry about the reducing. If the directions say reduce, then you change that to a 1/3, I think, right? Or 1/4. Or they tell you to change it into a decimal, you change it into a 0.25. When I do these problems, I'm not going to worry about reducing. Deal? Okay, y'all are all adults. Y'all need to worry about reducing. I'm just going to do the probability, and we're going to go from there. Now, somebody tell me what the complement of probability of a face card. Probability of not a face card. Well, what is the difference between 52 and 12? 40, right? So that would be 40 over 52. And I don't know what that is, 0.75. So that's the complement. I want you to do the complement whenever you can, because when we get to odds, you won't have a problem. So here's another one. And I won't end on this one. What is the probability of an even card? With ace being even. Okay? So let's go through and let ace being odd. With ace being odd. So let's write it down. Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, king, queen. Now, if you know anything about cards, you know that the face cards are all what? They're all even. They're tens. There's an even. 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 So in each suit, we got 3, 1, 2, 3, 4, 5. 8 cards that are even. How many suits do we have? Times 4 suits. So how many are even out of a deck of cards? 32. So the probability of even would be 32 over 52. What is the probability of not even? What's 52 from 30? What's 32 from 52? 20 over 52. So there's 2 test questions right there. Probability of a face card and the probability of an even card. Again, you have to know the cards. All right. So let's see where that leaves us as far as the 11.1 goes. So I think the only thing they're going to ask us to do next is odds. Let's see. I want to see how many. Let me go back. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 8. 8 slides, and it's just about cards. Okay, so you should be able to work on 11.1 homework. Okay, so everybody in the 155 class should be able to work after you watch this video. Should be able to work on 11.1 homework. Questions? Anybody
When
got?
is 11.1 due?
I'm sorry, what?
When is 11.1 due?
It's open right now. I haven't put a date on it because we haven't got toward the test yet.
Oh.
It looks like
Okay.
to me that we're probably going to finish 11.2 this week, probably Friday.
Mm-hmm.
So that means that next Monday or Tuesday or Wednesday, you're talking about going over the test. And that means that we'll probably be setting the date on the homework and the test. And that means after that, we got about 3/4 of a month to go over the autopilot section, which is the geometry / metric system section. If y'all have any questions on it, y'all should be finishing that up, or you should be sending me questions on it, because that's the one I told y'all after the 2nd or 3rd week of class that y'all need to be working on. So make sure you work on it. Look in your outline and be working on those, in your spare time, and send the questions. And of course, after we finish the test next week, that we'll have 3 weeks for nothing but questions on the autopilot section. Any other questions? All right, I'm going to shut down the recorder, and y'all have a good day, and I'll see y'all Wednesday.